Okay, on, sure. On these FRQs, the first question here, I have a graph, and you are gonna have, what are y'all doing? Look, y'all can stay downstairs, but you can't be loud, okay? Because I'm making a video, okay? What? You didn't even put the flag there. Hudson, come throw this away from me, please. Okay. I lost my train of thought. You are going to have a graph. It's not a lot of questions, but this is kind of a good limits review. So the limit as I approach 2 from the right side is going to go to 1. The limit as you approach 5. So this limit here is talking about the limit as a whole. So not the left or the right specifically, but together. So you have to consider the left and the right side, and both of those are going to the y value of 0. And kind of the same thing here. This is the limit as x approaches 7. And so because the left side is going to 2 and the right side is going to 4, the limit does not exist. All right, so for what values of x is f of x not continuous? Classify each discontinuity as removable or non-removable. So I'm gonna erase this stuff. On my graph, I'm going to have a discontinuity at 2, at 3, at 5, and at 7. All right, so those are all the values where you are discontinuous. So at the points, oh, good job, y'all were sneaky. All right, at the points 3 and 5, Hudson, leave Penelope alone. All right, go back upstairs and try again. All right, at the points 3 and 5, the limit is existing, but the point is up here. So there's a hole on my graph. And so those are going to be removable. So if you think about this point right here, I kind of picked it up and I removed it. So I'm going to say that at x equals 3 and 5, we have removable discontinuity. All right, now at 2 and at 7, my function is splitting apart. And so they're not meeting up. So at x equals 2 and 7, that is going to be non-removable because it's a jump. All right. On this next one here, I see y'all. I've got the limit as x approaches 7 of f of x. So I'm going to look at the limit as I approach 7 of f of x. All right, and so currently right now at 7, it's splitting up and it's not existing. So let's look at this. I'm going to do it over here so I don't have to zoom so much. So the limit as x approaches 7 on the left side of f of x. All right.
Did you see Hudson?
No. Y'all about to go upstairs. Hudson, go upstairs. Sadie, Hudson, Jacob, all y'all, go upstairs now.
Can you still play?
No, just upstairs now. Because I'm not dealing with that. Hudson, you want to go in timeout? Go upstairs then. As I approach 7 from the left side, I'm going to 2. So now I'm thinking about this as the limit as x approaches 2 of f of x. And so as I approach 2, and then these values here, this is kind of a tricky one. So this value is going from small numbers to big numbers. So this is still the left side. So as I approach 2 from small numbers to the bigger numbers, that is going to go to 2. So the left side's going to 2. So now I'm going to do the right side. So the limit as x approaches 7 on the right side of f of x. All right, so as I approach 7 on the right side, that is going to 4. So the limit as x approaches 4 of f of x, and then these numbers are going small to big, so going to be on the left side of 4. And then the left side of 4 is also approaching 2. So because the left-hand limit's approaching 2 and the right-hand limit's approaching 2, then I can say that limit is going to be 2. That one is kind of tricky. You do not have one on your test tomorrow. That's a composite function like that. So you do not have a composite function like that on your test. So if you didn't get that, not a big deal. Don't even worry about it. All right. How many values of c does the limit as x approaches c of f of x equal 1? All right. So 1 is right here. All right. So the limit's not going to equal 1 right there because it's breaking apart, but it will equal 1 right here, here, and here. So 3 times. 3 values. Woo. Okay. On your test, on what you should study for your test for tomorrow, I would know this part right here. All right, so this AP question is probably the least like your test. All right, this is kind of some of the old stuff. Don't worry about the composite and part C and D, not a big deal. All right, so let's look at number 2. At what is the value of the limit as x approaches c, and justify your answer? So this says I have a continuous function and I have this table of values. Well, if you look at your y values as you approach, x approaches 6, not c. As you're approaching 6, your y values aren't really approaching anything. So from the table, you can't really tell what the limit is. But because this is continuous, because f is continuous, that means that the limit as x approaches 6 of f of x has to equal the point. So when you're continuous, the limit equals the point, and this point here at 6 equals 8. State one value of k so that f of c equals 4 is guaranteed to have 3 solutions. So we want to hit 4 3 times. All right, if you're looking at your table, I know I'm going to hit 4 between 6 and 2. And so I also want to hit 4 between 10 and k and 8. So k can basically be any number as long as you're going to hit 4. So you can make it 3. Because between 10 and 3 you'd hit 4, and between 3 and 8 you would hit 4. You can make it 2 or 1 or -1 or 0 as long as you would hit 4 between 10 and k and 8. And that one doesn't say anything about justifying, so I can just put k equals 3. If f of x has a horizontal asymptote at y equals 3, what would be the corresponding limit statement? So for the limit of horizontal asymptotes, that is the limit as x approaches infinity of f of x. And when you're approaching infinity, you have to equal 3. You also can put the limit as x approaches negative infinity of f of x. So when you're talking about horizontal asymptotes, it's either positive or negative infinity. So either one of those, you don't have to put both though, just one or the other. And then explain why there's a value c on 7 to 10 such that f of c equals 5. So first thing is that I know f is continuous. From 7 to 10, my y values go from 6 to 2. So 2 is less than 5, which is less than 6. So by IVT, f of c equals 5. Okay, and then my last one, for what values of f of x does f of x have a vertical asymptote? So I'm going to first factor, oops, not -6, -3, -2. Now this guy right here is a hole because it cancels out. So that's not a vertical asymptote. Your only vertical asymptote is going to be at x equals 2. Justify your response because that's when the denominator equals 0. All right, so the limit as x approaches 3 of f of x. So when you're plugging in 3 into the original guy, you get 0 over 0, which is your indeterminate form. So then we are going to factor so the x minus 3 on the bottom, x minus 3, x minus 2. And when you cancel out your common factors, you are left with the limit as x approaches 3 of 1 over x minus 2. And when you directly sub 3 in, you get 1 over 1, which is just 1. Is g continuous at 0? Justify your answer. So now we're talking about the g graph. So when you plug in 0, you get e to the 0 minus 1. E to the 0 is 1 minus 1, which is 0. When you plug 0 into this guy, ln of 0 plus 1, which is ln of 1, which is 0. So because they're matching up, we are continuous. Now don't forget that statement. To prove continuity, the limit as x approaches 0, oops, not f of x, g of x, equals g of 0, which equals 0. So this is what you have to show to justify your answer. And then, of course, make sure you answer your question, yes, it is continuous. If h of x equals this guy right here, find the value of k so that you are continuous. So when you plug 2 in, you get sine of 2 pi. And when you plug 2 into the other guy, you get 2k plus 8. All right. And for this to be continuous, they both have to equal each other. On your unit circle, 2 pi is right here. That sine value is 0. Minus 8. K equals negative 4. All right, and those are some FRQ questions for what we've talked about thus far. Once again, I think the hardest one is going to be that composite function that I talked about on this one right here. And I think some people, I told y'all it was D&E and I was wrong. It's not D&E because I forgot to check the left and the right side. I just looked at the jump and I said D&E. So be mindful that you always check the left and the right side for composite functions. But remember, we don't have to worry about that till the AP test because we've already gotten past that unit, so no big deal. The composites won't be on this unit. All right, so we'll just review over that right before the AP test. It is not a super common problem that get asked, so I don't want you to worry too much about that. That would be like the really difficult limit questions, all right? But majority of your questions are gonna be kind of your basic limits, kind of like this. So don't stress about the limits and the composites. Make sure you know IVT, make sure you know how to prove continuity, make sure you know that horizontal asymptotes are as x approaches infinity. That's the stuff that you're gonna get tested on for this unit. So make sure you know all of that stuff. Yep, okay.